Welcome to Jonathan online class. In this particular class, I want us to look into this important topic, which is projectiles. This important topic that virtually almost comes out in every year WAEC. So for that purpose, there's a lot of demand for us to treat this topic, and I'm here for it now. So pay attention and enjoy the class with me. Now, this is a topic in physics, of course. Now, let us look at projectile. But before we go into solving problems involving projectiles, as involved in the examples on the board, I want you to understand what we mean by projectiles. What are projectiles? There are no material or object called projectile. Rather, it is descriptive or experimental. What do I mean? A projectile is any object or any material or any particle that is thrown into air or released into air or launched into air and they are allowed to fall freely under the influence of gravity. Any material or object that is thrown or released into air or into the atmosphere and they are allowed to fall freely under the influence of gravity, that is a projectile. And it usually describes a path of parabola. That is, the trajectory is parabola-like. That's a projectile. For example, when you throw a stone, when you use catapult to release the stone, that released stone now is now a projectile. If I throw this marker now into air, then the falling marker now becomes a projectile. If you kick ball, if you play table tennis, if you throw javelin in sports, so that is all these are projectiles. If you fire a bullet, so as it goes into air, it becomes a projectile. That is the basic concept of projectile. It can be objects or material can be projected horizontally. Maybe when you stand on top of a building or on a platform or in a tower or a tree and throw an object horizontally, that's horizontal projectile. I describe its own motion, it has its own properties. It can also project an object by inclining at an angle and release the object. When an angle is inclined to the horizontal as you release an object, then that one has its own property. It has its own description as well. We're going to see the typical examples in the calculations here. Thank you. Now let's look at the question on the board for clear understanding. Question number 1 is taken from horizontal projectile motion. So this projectile motion is motion under gravity. Yeah. Number 1 says a ball is projected horizontally from the top of a building 45 meters high with a velocity of 50 meters per second. Then calculate question A, the time taken to reach the ground. Question B, the range. That time, a projectile has time of flight, that time taken to reach the ground, to move, fly, and that time to fly and land. The range is the horizontal distance. Horizontal distance from the foot, from the point of projection to the point or the horizontal level where the object landed. That is the range. They can have the maximum height, the height of the platform, or the maximum height the object reached in air before landing. That's the word, the maximum height. These are important terms or concepts or quantities or parameters used for describing projectile. Then that is good. Okay, let's proceed to solution to this number 1 question without wasting time. I would like to use an illustrative diagram here. We are given this for that number 1. We have this. So this is the building. The body goes like this and lands. So it will describe a path like this. So the body moves out. This is the ball moves out. Then this is the initial velocity, the velocity. Then here is the height of the building. This is like the building. This is the building. This is the height of the building. The body moves like this and lands. This is the range, the horizontal distance. So that is it. Then we are given that the body was released with velocity of 50 meters per second. So U equals 50 meters per second. Then from the question, we have that the height is 45 meters. So here is 45 meters. 45 meters. The height. So we have the height of the building is 45 meters. 45 meters. Okay. Then, of course, we know that since it is motion under gravity, our acceleration due to gravity, whether given or not, is approximately 10 meters per second square. That equals 10 meters per second square. You don't forget it. It's a constant. Okay. Now, this is the illustration of the path taken by that body, released horizontally. Now, in this game now we are asked to find the time taken to reach the ground and the range. This is the horizontal distance, the range. taking it one by one. Let me make use of this space here for the time. Yeah, for the time. Okay. So the question number A says for A says the time. So for the time T equals square root of 2h over g. This formula is obtained from the fact that h equals ut plus 1 over 2 gt squared. That's where the formula is obtained. And under projectile, this is motion under gravity. Under projectile, we should know that u has no effect here, of course. So this will translate into 0. Because u has no effect along the height. For that reason, we have that h is equals to half gt squared. And if you make this subject formula here, mathematically, this is what you will get. Okay, so from this now, we have that square root of our 2 times our h is 45 all over 10 acceleration due to gravity. And that will definitely give us a square root of 2 times 45 is what? 90 over 10. And invariably, that will give us invariably square root of 9, which is what? 3 seconds. The unit of time is seconds. So the time taken by this object to land when released from this platform is what? 3 seconds with that speed given. Okay, the second question B asks us to find the range, or in other words, the horizontal distance from this foot of projection to point of landing. Then the range, for the range, question B, for the range of horizontal distance, we have that R equals UT, that's the formula. This formula is also obtained from this equation of motion under gravity, H equals to UT plus half GT squared. Then, under this horizontal level, G has no effect. Along this place, G is 0. G has no effect. Along here, U is 0. These are conditions. Because when a body is lying flat on the ground, the body has no effect. G has no effect on the body. The body is not, cannot fall again while having horizontally on the ground. So, because G has no effect here, half GT squared transforms into 0. So it remains UT. So R equals UT, which gives us U is what? Our U is 50. 50 times, and we have obtained T as 3 times 3. That will give us 150 meters, but it is distance. This means horizontal distance. Horizontal distance. Okay, so that is it. So we have answered the first question on horizontal projectile motion as given us in the example. Now let's quickly delve into number 2 question and treat it. Number 2, because we see an angle here, theta, number 2 is coming from the one that has to do with inclined angle. And it has its own description and solution. Now let's look at number 2, interpret number 2 question quickly. Then for number 2, without wasting time, number 2 question. Question number 2, let's describe it, illustrate it with diagram. We have a mental picture of that. We have this. So the body, this vertical, horizontal, the body was projected like this. So the body takes this part. This is the U, initial velocity of the body. Then the body moves and lands here. Then this point could be our maximum height. Maximum height attained by the body or before landing. So this place is the range, the horizontal distance of the body, the horizontal distance of the body from this point of projection to where it lands. That is it. So we are from here, we have that our U here from the question, the initial velocity of the body is 100 meters per second, 100 meters per second. And we are given that our angle theta is just an angle to horizontal, and our angle theta is 30 degrees, the angle of projection there. So of course, don't forget that our G is 10 meters per second square, being motion under gravity. Now you see that they have different descriptions depending on the path of the motion. Okay, now let's quickly apply suitable formula to treat the question. Let's quickly apply suitable formula to treat the question. Good. For question A, we are asked to calculate the time of flight, which implies the time taken by the object or the particle to reach the maximum height and the land. That's the time of flight. And it has the formula T equals 2u sine theta over g. That's the time of flight. That is it. So, having this, we have equals 2 times our u. Our u is 100. 100 sine 30 degrees all over g. Our g is 10. Now recall mathematically that sine 30 degrees is equals to 1 over 2 or 0.5 from our trigonometry ratios and functions mathematically. That is our SOHCAHTOA, sine, cosine, tangent. Good. So having known this, we apply it here. That is why you must marry mathematics if you want to be a good physicist or scientist as well. So we have this. Substituting, we have 2 times 100 sine, okay, times sine 30 0.5 all over what? 10. You can use 1 over 2 if you like. So that will give us 2 times 1, 0 cancel 0 here, which give us what? 20 times 0.5 over 1. And 20 times half will give you what? 10. Yes, that's what we have. 20 times half is what? 10. Okay, which is what? 10 seconds. So the time of flight is 10 seconds. 20 times 0.5, because 0 cancel here, 2 times 10, 20 times 0.5, you have what? 10 seconds. It's like saying 20 times 1 over 2, which is what? 10. Then B question, quickly. B question demands that we find the maximum height. For H maximum, we call it H maximum. We have the formula. The formula says U square sine square theta all over 2g. That's the maximum height. U squared sine square theta all over 2g. Okay? And that will give us U squared, our U is 100. 100 squared sine square, that is sine 30 all squared. Okay, that means times sine 30 degree all squared. That's the implication of this, sine square theta. All over 2 times 10. That's what we get. Then we proceed. When we proceed, let's make use of here. I haven't written the parameters. So, for visibility, now we proceed. And that will give us quickly, 100 square will give us 10,000. We have 10,000. 10,000 times sine 30 square. Sine 30 has been known to be 0.5. That's 0.5 squared. Good. Times 0.5 squared all over 20. That will give us 10,000 times 0.25 all over 20. Because 0.5 squared is 0.5 times another 0.5. And that will give us 0.25. Okay, then we continue. Then you should remember that 0.25 is the same thing as 1 over 4 mathematically. By equivalent. 0.25 is equivalent to 1 over 4. So I want to utilize 1 over 4 here because we are not using calculator in this operation here. And to tell you it is possible. So we have equals, we have here 0 cancel 0 here. That will give us 1,000. Of course, 2 divide 1,000 gives you what? 500. So we have 500 times 1 over 4, right? Because 0 cancels 0, remain 1,000. 2 divided 1,500. And 0.25 is equivalent to 1 over 4. And I will give you, then, 2 divided this one is 2. 2 divided 500 gives us 250. So, when you have 250 over 2, that will give you 125 meters. Correct? So, with that calculator, we arrive at our correct answer. So, that is 125 what? Meters as the maximum height attained by this object under projectile motion. So, this question C demands that we find the range, the horizontal distance, the range. And for the range, question C says for the range, that is R, equals, we have for range, let me claim here to find the last quantity. For the range, C, for the range, R equals U square sine 2 theta all over G. Please be mindful of this. This one is different from this. So students confuse these two equations. This is U squared sine square theta all over 2G. But this is U squared sine 2 theta all over G. Okay, which equals U squared is 100 squared times sine 2 times 30 degree. Now to simplify this, all over 10. And that will give us 100 squared is 10,000. It's very simple. You don't put other 2 zeros at the back. Simple. Then times sine 60 degrees. 2 times 30. You have to multiply by 2 before they find the sine function. All over what? 10. Which equals, let us clear this one first. 0 cancels 0 here, remaining 1,000. 1,000 times, then recall that sine 30 degree. Recall that sine 60 degree is equivalent to root 3 over 2. Yes, by special angle ratio in mathematics, which is also equivalent to 0.8660. That is it. So sine 60 degrees is root 3 over 2, which is equivalent to 0.8660. So times 0.866. That is what we have. Which is equals to, then you have to multiply this with a calculator. 1 0 here versus this. Then you have here 1 0 versus this, another one versus this, another one versus this, giving us now 866 meters. So that's how to multiply it. So when you have 1,000 times 0.866, you have 3 decimal places here, significant, versus 1,000. Each zero will eliminate 1 decimal, and you have 866 what? Meters. That is it. In case they ask you to find the maximum range, though it is not in our question, if you are expected to find the maximum range under projectile motion like this, remember that maximum range, arrow max, is equals U square over G. That's the formula for maximum range. In our case here, it will simply be what? 100 squared over 10, which is 10,000 over 10. You have 1,000. That's the highest horizontal distance the projected particle could have reached. That's the maximum range. And the maximum range occurs conditionally when the angle is what? 45 degrees. For the sake of objective questions. The maximum range occurs in projectile motion when the angle of inclination to the horizontal is 45 degrees. Thank you so much for your attention to this class. I remain your friend and tutor, Joe Newton. I believe with this you can tackle any challenge involving projectile motion, both horizontally and inclined with angle. It is still motion under gravity. Recall, we explained what projectile is in the beginning. Now, for more of these solutions in mathematics and physics, you can reach out to me through my WhatsApp number here. If you need extra classes on Zoom, Telegram, Verse,